Hey guys, in this session let us learn about how to measure the performance of an I/O for an Oracle database. So generally, what is meant by I/O? So I/O is input output, right? So if there is an input, for that input there will be some processing, and after that processing we get an output, right? So say for example, I execute a select query on the database, right? So once this select query is executed, it will go inside the shared pool and a lot of processing happens, and then it checks the buffer cache, then it scans the disk, and again we get an output, right? So here the select query is the input that I am giving to the database, and I get an output in the form of data like rows and columns, right? So similarly, internal to any database systems, right? So we have memory and disk. Okay, so I'm just explaining I/O at a higher level. So first, a process checks if the data is residing on the memory or in the cache. If the block is not available on the memory, then what it does, it issues an I/O. Okay, so I/O is a channel, we can say, or it is an interface, right? So it acts as an intermediate between the memory and the disk. So when this process sends a message or request to the disk, right? So disk controller contains the data, right? So this process will try to fetch the required data by checking the address, right? So there will be an address for each and every blocks which are stored on the disk. So with the help of the address, it fetches the data, and then it gives the output to the end user. So here input output means if the process does not get the data in the memory, it issues an I/O. So this is the I/O, right? It gives an input to the disk and get the data as output and stores in the buffer cache or memory, right? So what happens when this I/O itself is slow, and how to measure if I/O is slow or not, right? In terms of Oracle database perspective, there will be a lot of reads and writes, correct? So select query reads data, and insert, update, delete statements modify or write the data in the disk. So there are a lot of reasons for an I/O to become slow, right? So if the I/O bandwidth is very less compared to the amount of workload, then the I/O operation cannot cope up with the high workload. Or if the devices, right, all the disk devices are 100% busy, then the I/O or the storage controller can no longer serve the requests coming in, serve the I/O requests, right? So there will be some contentions and delays in giving the data, right? So that's where we get I/O performance. So in this case, there is a boundary between DBA, which is database team, and the storage or OS team, that a performance engineer or DBA should understand, right? So always if the Oracle database is responding slow, then application team will not directly go to storage team or OS team. First they will check with the DBA, right? Why? Because they execute SQL query, and that SQL query is ending up on the database. In the sense, this SQL query is hitting the database, and application team always expect the database to respond either fast or slow, right? So if the database is responding slow, obviously application team say that database is slow. For that reason, we need to make sure that there is a boundary between database, storage, or OS. Okay, every blame cannot be on the database end. In the sense, every time database is not responsible for the performance issues. So that's where we need to understand how to measure the I/O performance. Right. So in this case, we need to investigate from the database side and see if actually this SQL statement is not written well, or we need to change the code. Why? Because if this SQL statement is requesting for more data or expecting data than it actually requires, then application team needs to tune the SQL query, right? Or if there is any DBA parameters which are not set properly at the instance level, then DBA has to change those parameters accordingly, right? Say for example, if I have sufficient memory from the OS, but still my SGA or PGA size is very less, then I can just increase the SGA as per the requirement. So that's what we can do from the DBA side, or we can tune the SQL, right? Or we can just try to add an index, something like that related to SQL. And further, if still the database is not responding well, then we need to check the storage layer, right? All these layers are connected, interconnected, right? So DBA or database is residing on top of the OS, and OS has all these storage devices attached to these storage devices. So there is an interconnection between all these layers. So that's why we need to understand where exactly the issue occur, whether at the OS layer or storage layer, right? So if the issue is from the OS layer, then we need to check the kernel parameters and all, right? If the kernel parameters are set properly and the amount of user processes that needs to be connected from the from the application to the database is sufficient. So there are a lot of parameters that are involved from the OS layer, and also whether there is any leakage, memory leakage on the OS layer, or whether there is any leakage on the code layer. Sometimes some SQL may request more resource than it actually needed, right? So if I just write a loop, unnecessary while loop, say for example, so while loop acts based on Boolean conditions, right? If a condition is true, then it may execute, or if a condition is false, then it may execute. Until the condition becomes true, this while loop keep on executing infinite times. So these kind of leakage may happen in the SQL layer. So if there is a PL SQL procedure with the while loop, where actually the condition may be false, okay? So this while loop will expect the condition to be true until a certain condition met, right? And if that condition is not true throughout the lifetime, then this while loop keep on executing throughout the runtime of the database. So that is kind of another leakage. So application team need to tune the code. So likewise, if the issue is from the storage layer, then if there will be a lot of wear and tears on the physical side as well, right? If I have a storage array or controller, or say for example, if I'm having a computer, okay, and I'm attaching a hard disk to that computer, okay, and I'm using that hard disk for 20 years, okay. Out of wear and tear, that hard disk, the disk platter or the spindle is not performing well, or because of the age of that hard disk, 20 years, right? So the disk spindles are not interacting well, okay. There are some corrosions on the disk spindles, right? There may be a chemical reaction because of the acids which are there inside the battery or something like that, right? There may be physical harm as well on the storage side, so we cannot predict, right? And we cannot also see that unless until the storage the data center engineer go and check it, right? So likewise there are a lot of reasons, so every time database may not be the reason. So that's why we are going to learn the IO performance perspective. Okay, so let us just focus on IO performance. So there are two types of IO. One is read and other one is write. Okay, and read is further categorized into single block and multi-block reads. So what is single block read? The name itself denote only single block will be read at a time, and multi-block reads, multiple blocks will be read at a time. So we have a parameter for multi-block read, DB file multi-block read count, right? And this parameter determines the amount of blocks that will be read from the disk. So the values start from 2 and till 128. Okay, so this value is automatically calculated by Oracle database during the installation, but unless until if there is a specific reason to set these values, right? So if I have sufficient resources, then I can also use 128. If I set 128, then every time 128 blocks will be read from the disk. Okay, but this also multiplies the time, right? So if I set this value to 128, then 128 into the time, right? That is why single block read is faster than multi-block read. Why? Because only one block will be read. So just imagine if I read only one block, then time will be less, right? But if I read 128 blocks at a time, then just imagine there will be multiples of this one block, right? So systems where bandwidth is very bandwidth or throughput is very important, they can keep 128, right? But systems where response time is very essential, they can reduce the value. Okay, that depends on the type of application, right? So further, these single block and multi-block are categorized into synchronous, asynchronous. Okay, both multi-block and single block. What is synchronous? Synchronous means wait for an acknowledgement of an operation of IO completion, and asynchronous means does not wait for an acknowledgement of IO completion. So say for example, if there is a block in the disk, okay, so server process is trying to read this block. Okay, so it is issuing an IO. Okay, so if it is a synchronous IO, then what happens is until this particular block is read, the server process will not go to the next work. In the sense, if there is another block, okay, first server process needs to read this block, okay, then this block. Okay, so if server process is reading this block and it needs to get an acknowledgement saying that this block is completely read and it is stored on the memory. Okay, I'm just giving you an example. Okay, but if we go to internal layer, there may be a lot of other concepts as well, but at a higher level it works like this. Okay, and until there is an acknowledgement, this server process will not go and read the second block. But when it comes to asynchronous, server process will read the data. It does not care if there is an acknowledgement saying that this block is read or not. It will go to the next one without caring about the previous one. Okay, so that's why asynchronous operations are faster than synchronous IOs. Why? Because it does not wait for an acknowledgement, but here it waits until the acknowledgement is received. If acknowledgement is not received, then the server process will still wait for the acknowledgement. So there is a waiting process in synchronous, but asynchronous happens in parallel, okay, or direct IOs we can say. Okay, so we can also choose the type of IOs further from synchronous and asynchronous, either direct IO or parallel IOs and all these stuff that I will explain later. But this is the primary concept. Likewise for multi-block read as well. Okay, and synchronous IOs for single block read, expected IO average IO wait is 5 milliseconds, and for multi-block it is 10 milliseconds. So you can understand this by seeing the name itself, right? Since this is multi-block read, that is why we are giving this threshold as 10 milliseconds, because multi-block reads will obviously take a lot of time, but single block read will not take that much time. So that is why acceptable range of average IO wait is 5 milliseconds, which means if the single block IO is taking more than 5 milliseconds, then the issue is not from the database end. Okay, there are some exceptions where even if the threshold cross 5 milliseconds, issue may be from the database end, but as a rule of thumb and generic threshold, 5 millisecond is the acceptable range from an Oracle database administrator or DBA. If it is crossing 5 milliseconds, then we need to go and check with the OS or storage team saying that this is not the acceptable range as per Oracle, and please check if the issue is from the OS layer. So we need to check with the OS or storage team. Okay, similarly for multi-block reads, if the threshold cross 10 milliseconds, then we need to check with the storage team. And also remember that in general, not only for single block or multi-block, but in general, every IO which is happening on the database, the acceptable threshold of IO wait time is 10 milliseconds. If it crosses 10 milliseconds, then we need to check with the storage or OS vendor. Why? Because modern disks are very fast, right? In all the modern databases or the storage which are used are using SSD nowadays. Okay, even some infrastructure are using flash disks as well, NVMe and all these stuffs. So all modern disks will be quite faster compared to the traditional disks. Okay, so that's the reason 10 millisecond is the acceptable range for overall IO. And we can see the wait events, right? We know about the wait events. DB file sequential read is for single block, and DB file scattered read is for multi-block. Right? Sequential read will read one block at a time, but scattered read reads multiple blocks at a time with the help of this parameter. And every blocks which are read should be 1 MB size. Okay, so coming to writes, so writes are also similar. They have synchronous and asynchronous. Okay, so these are just generic concepts, but may not be applicable for every storage vendors or OS vendors. Okay, but because each and every OS or storage vendors may be having their own way of architecture and behaviors. Okay, this is just a generic concept for which you need to understand. Okay, so writes can also be categorized into synchronous and asynchronous. That's it. This may differ for, as I already told you, for different storage vendors. Let us come to measurement. So how we will measure an IO performance? We either measure through response time or throughput. We already know that response time means online transaction processing, like banking sector, and throughput means OLAP, like e-commerce sales sector. historical data. So these are real-time data or real-time transactions. So milliseconds for a task is the primary target of response time, which means how much time it is taking for the task to complete. That is what focused on response time. But for throughput, how many number of tasks are completed per unit of time. Okay, so in response time, we don't care about the amount of work done, but we care only about the time taken for a task, particular task. But here, we care about the amount of work done for a particular amount of time. Right? So say for example, if I run a select query, I am primarily focused on the time taken for that particular select query. I don't bother how many select queries are executed, whether 10 or 15. I am focusing only on one query, and that query needs to be completed in 1 millisecond, say for example. That is the primary goal of response time. But for throughput, I focus on the number of select queries. So how many number of select queries are completed within a particular time. So say for example 10 select queries are executed in 10 seconds. So this is an example of throughput. And how we can measure the response time with the help of Oracle wait events. Okay, Oracle automatically record all the waits in terms of wait interfaces. So we can use those wait interfaces using AWR or VWR views, Ash and all these tools to check. And for throughput, we can check the IO stat. Okay, so let us come to the generic IO threshold for all the IOs. As I already told you, 10 millisecond is the universal acceptable wait, average IO wait for all the Oracle databases. Okay, but still we can further reduce it to multi-IO, single IO. As I already told you, single block reads is 5 millisecond and multi-block read is 10 millisecond. So these are the acceptable range to measure IO from Oracle database. It's not for OS. Okay, so if the average IO wait or response time is 100 milliseconds, then this is an issue from the OS layer. Okay, so we don't need to check or further take the overhead. Okay, we can directly reach the OS or storage vendor. And for log IO, so this is very important. For every log which are happening on the database, 3 milliseconds should be the IO response time. That is the reason all the online read log files needs to be placed on faster disks. Okay, this is the recommendation by Oracle. Why? Why? Because all the changes which are happening on the database are recorded for recovery with the help of these logs. Right? So that is the reason if the IO response time is very slow for these data, which is very crucial for the recovery, then obviously there is no point in recording these logs. Right? If log writer is acting like DB writer, then definitely every Oracle database or every failure which are happening on the database will be either with data loss or something like that. Why? Because DBWR is a lazy writer. It writes, it does not write every fraction of seconds. It writes when there is a checkpoint. But log writer needs to switch every fraction of seconds, and it needs to write all the redo data or the log data from log buffer to redo log. So that is the reason 3 millisecond is the acceptable range. If it is going beyond that, then Oracle recommend to put all the read log files on a faster disk. Okay, but even still, if the log IO is greater than, the response time of log IO is greater than 3 milliseconds, then we need to check with the storage vendor. Okay, and there are IO outliers. Okay, this is very important. So this is how we can measure the odd man out, we can say. Odd man out in the sense, so there is a graph, just consider. Okay, so in this graph, I measure the IO performance. Okay, so here I am plotting IO usage. Okay, so here I am plotting the time. Okay, so in this case, just the graph is like this. Okay, the points are somewhere near 1, and suddenly at one particular time there is a spike, and again it goes down. Again it the IO response or IO usage is down. Okay, so in this case, when we calculate the average or cumulative data, okay, this particular spike will be hidden, or it will not be visible when we check an overall report, overall or average report. So that's where this IO outliers come into picture, right? Why? Because this is an outlier, right? So what is outlier? Outlier is something which is something different or away from the original mean or median, right? So if we calculate mean for a particular task or anything, for the amount of data or for the amount of tasks which are performed, anything, so we can say that which is something away from the average. So on an average, my IO response time or IO usage is only 1, but an outlier has happened at 4. So if we take a real-time example, we can take the salaries, right? So this is a very common example where we hear it too often. Okay, if we calculate the salaries of everyone on the world, and if you just calculate the salary for the top 10 richest persons, almost 90 or 95% of the salary will be at 1. Okay, so you just include these top 10 richest persons salary with the remaining 90 or 95% of the salaried people, then you will see the graph suddenly increasing at one point, and then again it goes, which means only these top 10 richest person, which means only 1% of the people are earning too high compared to the average salaried persons. So this is an outlier, right? So likewise, these outliers are very important because these data will give us a lot of informations during troubleshooting. So that is why when we troubleshoot, a lot of spikes will be hidden because of the average calculation of the data. So this outlier will record all those spikes, okay, so that when we troubleshoot, we can go and check whether there is any sudden spike on the average. So these are the views: $V outlier and $V log writer outlier. and there may be short bursts of IO. So that's what I told you, right? Sudden spike. Okay, so say for example, for 1 millisecond, there is a short bursts of IO, but that short burst of IO may not be recorded on the reports, either on the AWR report or any report. We may not be able to identify granular informations. Granular means these are very small or tiny informations which will be hidden on the graph. Okay, so if we come to wait events related to IO, we don't need to think a lot, or we don't need to memorize all the wait events. There are only two categories. Okay, one is single sequential read write. So there may be some exceptions, but almost 90% of the wait events will be like this. Single sequential read write, direct parallel read write. So I will give you an example. So sequential, DB file sequential read. So here sequential and read, and DB file scattered read. That's what I told you. This is an exception. Okay, why? Because there is a word called scattered, but read is there. So scattered is only exception. Okay, so DB file parallel read, another example. This is one wait event. Here you can see parallel read, DB file single write. So likewise, most of the wait events are categorized in these two, and every direct or parallel read writes will be asynchronous multi-block reads. So here we seen, right, single block, multi-block, synchronous, asynchronous. So same thing, asynchronous multi-block read. All the direct or parallel wait events, parallel read write, and single sequential read, all will be synchronous single block. Okay, synchronous single block. Every wait events which are coming with the name single or sequential will be synchronous single block. Why? Because why I'm telling you this? Because of the threshold. Right? How you will check whether this particular wait event threshold is 10 millisecond or 5 millisecond. So wherever you see single or sequential read write, you need to check if the IO threshold is 5 millisecond or less than that. If it is beyond that, then we need to check with the storage vendor. That's how we measure. So only exception is scattered read, DB file scattered read, which is synchronous multi-block. That's it, simple. Okay, so synchronous multi-block, that's it. And again, if you just map this multi-IO, it is 10 millisecond. For synchronous multi-block, the acceptable IO wait time is 10 millisecond, that's it. Why? Because as I already told you, the name itself denote, right? Single block means reading single block at a time, but multi-block means we need to allow some time for the multi-block, right? We cannot simply say that for multi-block also 5 millisecond, because multiple blocks needs to be read, which makes sense. So for reading multiple block, obviously it will take some time. So that is the reason for synchronous multi-block also we can accept for 10 milliseconds. That's it. So if you need to categorize or simplify the wait events, you can simplify like this. Okay, instead of giving you all the wait events, I have just categorized all these and simplified all these events into a smaller form, so that it will be easy for troubleshooting. Right, so if I give all the wait events, there are almost more than hundreds of wait events related to IO. that we cannot remember each and everything, because they may change between the versions, right? If it is 19C, the term may be different, or they may further update the weight events. There may be 200 weight events, 300 weight events based on the versions. So that is the reason it is always easy to rely on this simple chart. And next, let us focus on triage path. So when we generate an AWR report, we check the top 5 foreground events, and we should check the tablespace file IO stats for the average IO response time. Also, we can check the weight event histogram and check for the high millisecond bucket. Right, as I already told you, IO outliers are very important. So in this weight event histogram, there will be a lot of buckets. Okay, so how much IO was spent on 1 millisecond, how much IO was spent on 2 millisecond, and how much IO was spent on 10 millisecond. Likewise, lot of buckets will be there. I will explain you in the practical class so that you will understand this. Okay, this means that how many number of IOs took 1 millisecond for an operation to complete. So that will be stored in a particular column. And how many number of IO requests took 2 millisecond. So this is where we can isolate the outliers, right? If if a particular IO or set of IOs are taking 1 seconds for respond, then we need to target on this 1 second IO response time. Why? Because in terms of storage or IO, 1 second is very high. Okay, it is not a real time or it is not a physical in the sense for humans 1 second is very less. Okay, 1 hour may be high, but 1 second may be less. But in terms of storage or database or OS concepts, 1 second of IO response time is very high. That is the reason I am stressing on this point. Okay, when a non-DBA check this report, he will say 1 second is very less, so there is no issue. But a DBA, when he filter a lot of things and see 1 millisecond is similar to 1 hour in storage terms. So that is the reason when the IO wait time is 1 second, obviously we need to focus on that particular area, whether the issue is from database or whether the issue is from storage. Okay, but 1 millisecond is fine. Okay, so that is the reason we use weight event histograms. Okay, and in top weight events, we check conventional IO or direct IO. So we can go to SQL ordered by reads or SQL ordered by physical reads unoptimized. So that we'll see in practical class. Okay, so this is how we measure the performance of IO in an Oracle database. And IO is mandatory or necessary in every database. We cannot ignore this. Okay, majority or 60 to 80% of weight events may be related to IO in any database. Why? Because IO is not avoidable. I mean, IO is not unavoidable. Okay, why? Because it is part of regular database operation, right? Like how a human cannot avoid drinking water, right? Without water, human cannot survive for a long time. So likewise, without IO, there is no database, right? Even though the database is idle, still it may do some internal activities or something where IO is needed. Okay, so that is the reason it is very important to know the measurements of the IO performance.